This is Summer 10.0, dealing with surface area and volume. 10.0 comes after 10.9, 7 point, excuse me, 10.0, excuse me. 7.10 comes after 7.9. 7.10 is completely different from 7.1. It is not, it is not the same. As a decimal, it is, but as a as a chapter, it is not. Surface area and volume. I love surface area and volume. I guess I say that a lot, don't I? I say I like all of these. So it says find the surface area of a prism. First thing we should know are two base figures. Two base figures. When it's a polygon base, polygon opposed to a circular base, polygon base. A two base figure that is a polygon is called a prism. A circular base would be called a cylinder. When you have a one base figure and you have a polygon base opposed to a circular polygon base with a one base figure is called a pyramid. And with a circular base, when it only has one base, that's called a cone. And then the other figure that we have is called a no base. No base figure is called a sphere. A sphere does not have any base. Polygons and all circular cylinders, all circular two base figures will always be called cylinder. It doesn't matter how big or wide your radius is or your diameter, it is always going to be called a cylinder. And these are always going to be called cones. Now, depending on your base for your prism, it does matter. So you can have a square prism. You can have well, I guess we'll go with three sides. You can have a triangular prism. You can have a square prism. You can have a rectangular prism. You can have a trapezoidal prism. You can have a parallel, no, not a parallelogram. We call that I guess you could. Parallelogram. Polygon. I don't think anybody's ever called it a parallelogram prism, but it's okay. Rectangular, and then you can have five-sided is a pentagonal prism, etc. Pentagon. We'll at least put pentagonal. And that also goes for all of your pyramids. You can have a triangular pyramid. You can have a square pyramid. You can have a rectangular pyramid. You can have a pentagonal pyramid. You can have a hexagon, etc. So all of the prisms and pyramids will have a name in front of it depending on the shape of the base. So polygonal bases are prisms, circular bases are cylinders. Two base, one base. So that's important. That's why this is a prism. This is a rectangular prism. And a rectangular prism, there's a couple of ways we can do this problem. I'm going to do it the formulaic way. So surface area is going to equal the base area plus the lateral area. So the bases can be, and we can show this, we'll make this the base. The top is going to be the base, and so when we talk about the base area, we're talking about the top of the figure. And if we want the other base, because bases have to be parallel to each other, it would be the bottom of this. So when we talk about the base area, we're talking about the bottom and the top. So the base area, well, the base area is going to be length times width, and we have two of them because we've got our top and our bottom. And then the lateral area, this is the interesting part. I really like this concept because it's very important to be able to see this. So the lateral area is sort of like our waist. It's the waist of the problem, meaning it goes around the figure and we go around. So it's the waist is this part of the figure. It's what goes around it, around the waist. So we see this part. Okay, so it's this around, and that if we pull it apart, and we get to understand it through nets, a net. So if we open this up, you'd have the top, you'd have the bottom, and then you'd have the waist, right? We'd have this. So that would be our diagram here. This is the top, this is the bottom, and then this is the left, this is the front, this is the right, and this is the back. So you have these 6 sides, and this is going to be our lateral area. These two are going to be our base areas, and that's why we said times 2. And then the lateral area is a rectangle. You see it's a rectangle shape. So it's really, if we're going to find this area here, this is length times width, or the height of the object. So this distance is going to be the height of the object. That's going to be this part. That's the height. And this width is actually going to be the perimeter around the object, because notice if we unfold it, this distance is going to be the perimeter. So really what we have is we have perimeter times height. I like that formula a lot. And so if we want to start plugging in values, the base is going to be the length. This is the length, which is 7 miles, times the width, which is 6 miles, plus the perimeter. Now the perimeter is going to be the distance around the object, 6 plus 7 plus 6 plus 7. So that's going to be 6 miles plus 7 miles plus 6 miles plus 7 miles. And then that's going to be times the height, which is 3 miles, times 3 miles. And I ran out of space quite quickly. So this is going to be 2 times 7 times 6 is 42 miles, times miles is miles squared, plus, now 6 plus 6 is 12, 7 plus 7 is 14, which gives us 26. So that's 26 miles times 3 miles. Let me just make sure, yeah, 13 and 13 is 26. Sorry, I don't think I needed that little parentheses. So we have these two calculations, and let's multiply 2 times 42, which is 84 miles squared, and 26 times 3 is 1878 miles squared, because miles times miles. And then we're going to add up 84 and 78, which is 162 miles squared is going to be the surface area of that object. And notice they provided you with the unit already. So I like that technique. I will show you another technique that you can use. Let's clone the page. Let's erase, clear the ink. All right, the other technique that you can use is we talk about the faces. So the faces, you have the front, That's here. This is the front. You have the back, which are identical. This is the back. You have the left, which is over here. You have the right, which are identical to the left. And then you have the top, which is up here. And you have the bottom, which is down here. And these are identical. So these are identical, these are identical, and these are identical. And that's not a bad way of working it. It's also systematic. So the front is 7 by 3. Now that's where you have to be a little careful. I like doing this. 7's real easy, but this one's the hard one. So what I like doing is something like this. Maybe we can do this. So we want to find that distance. It's unknown. So what we can do is we can grab it and, well, it's not parallel to this. It doesn't overlap with 6, but it does with 3. So I know this unit is 3. So this piece is 3. If we find another one, if we pull it along 7, anything that is parallel to it is also going to be 7. This is 7, this is 7, this is 7. And then we can also do it for the 6 miles. So this is 6, this is 6, this is 6, and this is 6. So that's a nice technique to find out what those missing lengths. So the front shape is a rectangle, so we're going to multiply. We're going to multiply 7 more whoopses. We're going to multiply 7 miles times 3 miles to get 21 miles squared. I know my back is congruent, so that is also going to equal 21 miles squared. My left, now there are no dimensions here, so that would be where my thing. So this is 6 and this is 3. So left is going to be 6 miles times 3 miles, which gives us 18 miles squared. My right is congruent, so that's also going to equal 18 miles squared. My top is 7 by 6, 7 miles by 6 miles, which gives me 42 miles squared. And I know my bottom is going to be congruent to that. So that gives me 42 miles squared also. That's probably less abstract than this. This, you really got to know your formulas. You got to understand the shape really well. And this is definitely efficient. And this is a high school technique. But I understand how at this stage developmentally that still might be somewhat challenging for you. So now we add them up. That's 10, that's 22. Carry the 2, 2, 4, 6, 8. 8 and 8 is 16. 162 miles. Cool. Good. All right. Find the surface area of the cylinder. Surface area of a cylinder has a formula. It's still based upon this. It is base area plus lateral area. The base area are the 2 tops and bottoms. So those are 2 circles, 2 pi r squared, plus the lateral area. When we unzip the lateral area, you actually get a rectangle. And here's the top, here's the bottom. So you get this, which is actually, again, remember it was the perimeter in a polygon. It's actually called the circumference. It's the circumference, and this is the height. So the circumference is going to be 2 pi r is the circumference, and then you times it by height. So that formula for every single cylinder for the surface area is 2 pi r squared plus 2 pi r h. And we can plug in values and substitute them. Move please. Thank you. So now we can plug in we'll use 3.14 for pi times the radius, which is 6 centimeters quantity squared, plus 2 times 3.14 times the radius, which is 6 centimeters, times the height, which is 14.4 centimeters. So that gives us 2 times 3.14 times 36 centimeters squared, plus, we should do 2 times 3.4. That's going to be easy. 6.28. 6.28 times 3.6. Don't need this. Plus 2 times 3.1 is 6.28. 6 times 14.4. 6 times 14.4. 6 times 14.4 gives us 86.4. 86.4 centimeters squared, because we have centimeters times centimeters. And now we have, we can put parentheses there. We have 6.28 times 36. 6.28 times 36 gives you 226.08, 226.08, 226.08 centimeters squared, and 2.6, 86.4, 86.4, 86.4, 2.8 times 86.4 gives us 542, 592, 542, 542, 592 centimeters squared. Let's add those two up. Add it up. Add it up. 226.08 gives us 768. 768, 672, 768. I've already forgotten. There's my deficit. You want to know why I didn't do well in school, in high school? Was because I have that short of a short-term memory. I can't even remember those other three digits. 768, 672. But I can do math really well. That should be the surface area of the figure. Round your answer to the nearest tenth. Okay, so reading directions. Notice we weren't just done. We didn't just circle it. We actually went and made sure that we answered the question correctly. Gosh, this thing is really hard to move. So if we're going to round it to the nearest tenth, 768.7 centimeters squared. I think the book says 769.1. That's okay. This is close, as long as I did all the math correctly. I could have made a mistake. Definitely could have made a mistake. 36, 3.14 times 2 is, 628. That's correct. So it's off by a smidgen. Find the surface area of a regular pyramid. Ooh, I like this. This again is still surface area equals base area plus lateral area. Now the base area, there's only one base, so we don't have to multiply it by 2. And my base shape, it said it was a regular pyramid. That means it's a square. Regular means all sides are equal. So we have a square. So this is going to be one base, which is s squared. That's the area of a square, plus the lateral area. So if we unfold all that, if we zip it open, if we take off the bottom, we're going to notice that we have 4 triangles. 4 times base times height divided by 2. We can simplify that. side squared plus, now the 4 in the numerator and 2 in the denominator cancels, so we're left with 2 times base times height. So the square is 8.4 feet squared plus 2 times the base, 8.4 feet times the height, which is 12.6 feet. And so 8.4 squared, let's use this instead of losing my page all the time and having to remember. Do you remember? All right, hello. I'm not even doing it correctly. 8.4 squared equals 70.56 feet squared, plus we got 8.4 times 12.6 gives us 105.84. 105.84 feet squared. And let's double that because we're timesing it by 2. Gives us 211.68 feet squared plus the 70.56 feet squared plus 70.56 gives us a grand total of 282.24 feet squared. Tells us to, no, it doesn't tell us to round anything. So that would be my answer, 282.24 feet squared. All right, good. And if you wanted to do it by sides, you could do the bottom. You can do each of the triangles with a base and a height. Remember, height has to be perpendicular. This is actually called the slant height. So that's kind of important. You wouldn't use this in volume. You use your slant height. This is called the slant height. And then the real height of the object goes to the center of the object. And it goes to the interior. That would be volume because volume is inside. Surface area is outside. So this is called the height of the object. This is the slant height, which is on the surface of it. Find the surface area of a regular pyramid. This time we have 3 sides. It's still, so this is actually our base is equilateral triangle because all 4 sides are the same, or all 3 sides of the triangle. So we could still use surface area equals base area plus lateral area. My base area is going to be a triangle, so that's base times height divided by 2. And my lateral areas, this time we're multiplying by 3 because there's 3 triangles, base times height divided by 2. Different triangles here. This is my base, which is a different triangle from my lateral area triangles. This is my base triangle, which has different dimensions than my lateral area triangle. So very important to keep track of those. This base is not going to be this base, or etc. Actually, it may be the same base. It'll be interesting. Yes, it is. So 5.5 millimeters times the height of the base, which is 4.8 millimeters, divided by 2. Let's just move this stuff over so I don't run out of space. And then let's add for the lateral area is 3 times, now the base is going to be the same, 5.5 millimeters times the height. Now this is the height of the lateral area triangles, which is 11 millimeters divided by 2. So we're going to have 5.5 times 4.8, which equals 26.4 millimeters squared divided by 2. Gives us 13.2 millimeters squared. And that's going to be 5.5 times 11, which gives us 60.5 millimeters squared divided by 2 gives us 30.25. 30.25 millimeters squared times 3 gives us 13.2 millimeters squared plus 90.75 millimeters squared. Let's add that to 13.2, which gives us a grand total of 103.95 millimeters squared. Are we rounding? We're not rounding. And let's check the answer, make sure that we are correct. 103.95. Let's go, baby. Find the volume. Okay, volume now uses the formula. Volume of all two base figures. That means prisms and cylinders will use volume equals big B times H, where big B equals my base area times my height. So I have to choose my base area. I'm choosing the bottom as my base area. So that's going to be this, the bottom of this figure. That's going to be my base. And then my height is going to be the height of the object. So that's kind of nice. So we first insert what my base shape is rectangle, so length times width times the height, and my length is 8 inches times my width is 8 inches times my height of the object, which is 5 inches. That gives us 64 inches squared times 5 inches gives us 320 inches cubed. Very important for us to understand that it's going to be cubed now. 3 dimensions, we're multiplying 3 dimensions, length times length, width, and height. So our answer is going to be 3 dimensions, 3 to the 3rd degree. The base of a hexagonal prism has an area of 82 square inches. The height of the prism is 4 inches. Find the volume of the prism. Okay, this is nice. So hexagon. Does a hexagon have 6 sides? Right? Hexagon has how many sides? I think it's 6. 6, yeah. Has 6 sides. So I just wanted to draw a 6-sided figure. Nope, that's not it. Here we go. 6 sides. So that didn't go on an angle. I was kind of hoping it was going to go on an angle, but that's okay. We can still do it. So this is what it kind of looks like on its side. Hey, not bad, right? Mr. Mac's not bad at drawing. Yeah, we'll draw it there. We'll draw it like this. And we'll draw it like this. Once I get it, it's a little bit easier to draw it appropriate. That's okay. So there is our hexagonal prism. We actually have sides. Ooh, let's do that. We can get real technical. I know. This video is already long enough, Mr. Mac. Well, that's okay. I'm just going to go along there. And it's going to go along there. And that's going to go along there. That's going to connect up there. That's going to connect up here. And there is our somewhat. So our base area, and our base is going to actually be our front and back because they have to be parallel to each other. So this base area is going to be the front. We're going to consider the front the base area. So that base area is going to be 82 inches squared. And then it says the height of the prism is 4 inches. So the height is going to be the distance between the two bases. So that's going to be that distance. And so our height, even though, we would want to turn it to see, the height is just going to be the distance. Height, we think of bottom to the top. But in this instance, the height is important to see. So we're going to use the formula. We still use the formula V equals big B times H. And our base area we're already given, which is 82 inches squared. And the height is given, which is 4 inches. And we're going to multiply those together. And we get 328 inches cubed. Yep. 328, yes, good, perfect, love it. That's question number 6. The base of a rectangular pyramid has a length, okay, 4 inches, the height of the pyramid, find the volume. So this time, when we have one base figures, volume equals 1/3 big B times H. So pyramids and cones will have this formula. So volume equals 1/3 big B times H. And the base of a rectangular prism has a length of 4 inches, pyramid, and a width of 3 inches. Rectangular pyramid. Okay, so we've got a rectangle. Let's draw that rectangle. Kind of looks like that. As you see, Mr. Mac likes to draw. So we get these up in front that we can see, and then that one in the back we cannot see. So that's what our rectangular prism. It has a length of 4 inches. It has a width of 3 inches, and then the height of 5 inches. Notice it's not going to be the slant height. It's actually going to be the interior height. We talked about that earlier. So that interior height is going to go here, and that's going to be 5 inches. So when we look at this, the base area is a rectangle. So we have 1/3 times length times width, sorry. Because a rectangle is length times width times the height of the object. Volume equals 1/3. The length is 4 inches. The width is 3 inches times the height, which is 5 inches. Now, a lot of people would multiply 4 times 3, but I see that since we're multiplying everything, this is in the denominator, this is in the numerator, they can cancel to make 1. So now I'm just left with 4 times 5, which is 20. I have inches times inches times inches, which is inches cubed. So we'll be left with 20 inches cubed. That's the efficient way to do it. That's what we're looking for here. The base of a triangular prism has 4 inches, 3 heights. The height of the Is that the same question? Is that literally the same question? No. Must have changed something. No, it didn't change anything. Oh, triangular pyramid. Sorry. Okay. Had to sort of take a second there. Triangle. Very important. Had to stop and read. This is a triangle. This is a rectangle. Even though they have the same, that was kind of tricky. They were getting very tricky on us right there. Let's take, no, let's not take that one. Let's take this one. So here is my base of my triangle. And it's going to look like that. Pyramid, 4 inches. My base is 4 inches. So this is going to be 4 inches. We would assume that this is perpendicular. And the height is 3 inches. And then the height of the pyramid, again, from the interior up to the top, is going to be 5 inches. We still use the formula. volume equals 1/3 big B times h, where the base shape this time, instead of it being a rectangle, is a triangle. So base times height divided by 2 times the height of the object. Base of the base triangle is 4 inches times 3 inches divided by 2, and then times the height of the object. We again see that we have a denominator and numerator that are identical. And now we also have 2 and 4, so that becomes 2. So we have 2 times 5, which is 10. Inches times inches times inches is inches cubed. So this volume is going to be 10 inches cubed. Match the figure with the description of the intersection of the plane and the solid. So that's going to give us a circle. Intersection is a circle. Circle. That intersection is a triangle. This intersection is a rectangle. And you will learn very, very interesting how these, if you have a cone, the intersection of a cone actually creates different shapes, which is really cool. We're gonna nerd out a little bit more. Intersection of a circle actually creates circles and ellipses of a circuit. Sorry, intersection not of a circle, of a cone. With a plane, yes, I probably should have said with a plane. With a plane. Produces very interesting things. So we notice that you can get a circle if it's parallel to its base. Here we go, here. Look at this one too, that's pretty cool. We can get a circle, we can get an ellipse, we can get a hyperbola, and then we can get a parabola also. So that's kind of nerded out. And here's another good example. You get a point, you get a circle, you get an ellipse, and then you can get a single line if that plane is along there. You can get a point, you can get a triangle, you can get a half circle or hyperbola, or a parabola. So I know, I don't know. It made me think. It's kind of interesting to me. Okay, where are we moving on to? The base of a triangular prism is a right triangle with a base of 6 inches, height of 8 inches, and a third side length of 10 inches. Okay, the height of the prism is 14 inches. Find the surface area of the prism. Now this is good because we're going to have triangles still, but those triangles are going to have different bases. So before, when we had a regular bottom, where all the sides of the triangle were the same, not there, not there. This, no, not there. That's, oh yeah, these are regular. So it says a regular pyramid. So this side is 5.5, 5.5, 5.5. That's not going to be the case in this example. We actually, as I stated, you get a right triangle. It's a little bit more like what I had drawn here, how we said that this was a right triangle. But this is finding the volume. We're going to find the surface area. So finding this triangle with this base, this triangle with this base, etc. That's why it's important to determine that, to understand that concept. I guess we can do it kind of like this. Let's do this. Let's rotate that a little bit, and we can draw some lines up to that pyramid. Let's fix that one line. So that's what it looks like. And this is a right triangle. We have a right angle here. And so this side is going to be right triangle with a base of 6 inches. So we'll put that 6 inches, a height of 8 inches. And then this back side, this third side, which is called the hypotenuse, is going to be 10 inches. And then the height of the prism is 14 inches. Now, that's a bad word. It can't be the height. It has to be the slant height. And is the slant height going to be the same on each of those? Yeah, I guess it should. Slant height. That's a bad wording because height would be interior, and interior doesn't help us. So we're assuming that the slant height for each of these, because we're finding the surface area, that's the outside, height is interior, slant height is exterior. So each of these is going to be 14. So we actually have surface area is going to equal our base area plus, now typically lateral area is one formula, which it is, but because there are three different faces, we're going to have to do three different ones. So you're going to have base times height divided by 2. That's that bottom triangle. Then you're going to have base times height divided by 2 plus base times height divided by 2 plus base times height divided by 2. These are the three bases. Sorry. So let's start with our base area. That's 8 inches times 6 inches divided by 2 plus, let's do this first, which is 8 inches times 10 inches divided by 2 plus, I'm running out of space. Let's move all of you over, please. Whoop. Plus, let's go the back one, 10. Oops, sorry. The height is 14 inches. Sorry. This should be 14. 10 inches times 14 inches divided by 2 plus, let's do the right one, which is going to be 6 inches times 14 inches divided by 2. Let's cross cancel here. Let's do 2 into 8, which gives us 4. Let's go 2 into 14, which gives us 7. 2 into 14 is 7. 2 into 14 is 7. And now let's multiply. So that's 24 inches squared plus 56 inches squared plus 70 inches squared plus 42 inches squared. Add those all up. Let's do some mathing. 24 plus 56 plus 70 plus 42 equals 192 inches squared for the surface area. That ain't it. What didn't I do right? Triangular prism. 6, 8, 10. I must not be mathing correctly. It says surface area. Yeah, see, I think they're doing it wrong anyway. So, am I supposed to find? No, I'm not supposed to find something. What do you think I did? Can you see? And this is the best, is when I go through a video and kids are watching it and they see a mistake and they're like, wait, Mr. Mac. They're screaming at the video. Stop, Mr. Mac, you made a mistake. And I don't notice it. And then maybe like 10 minutes later, I go back and fix it. So I just, am I doing something wrong here? I have base times height. These are triangles. That's a triangle. Find the surface area of the prism. I have my base area plus my 3 lateral areas. That's correct. I'm not multiplying anything. I'm just adding each of those surface areas, the bottom, left, right, and back. That's half. I did half. 24, 56, 70, 42. Did I not add correctly? I think that's correct. Oh, that looks correct in number-wise. I think it's this height is 14. That height is 14 is a little bit interesting. The height of the prism is 14 inches. Third side length is 10 inches. Oh, prism. Not a pyramid, Mr. Mac. Prism. That's where. So notice, this is really, really good. Prism. So this is why it's really beneficial. Because even I'm going to make a mistake. So we have to be able to, and it was funny, one of the things is because the height, it was the height. I'm like, they didn't make a mistake. It's actually the height. Yes. So this is not my figure. My figure actually looks like this. Sorry. Looks like this. And we can copy that. Edit, copy, and paste. And it looks like this. Duh. Mr. Mac. Silly Mr. Mac. Okay. And the height is 14. And we still, now we get 2 base area, right? Oh, sorry. So we get 2, the base area is going to be 2 times base times height divided by 2 plus the lateral area, which is going to be the perimeter times the height. So the 2's will cancel. We're left with base times height equals perimeter times height. Base times height is going to be 6 inches times 8 inches. The perimeter is going to be 8 inches plus 6 inches plus 10 inches times the height, which is 14 inches. That gives me 48 inches squared plus 8 plus 6, 6, 12, 14, 24 inches times 14 inches. 24 times 14 gives me 336 inches squared plus 48 inches squared gives me 384. 384 inches squared. I'm sorry, but this is a great thing, is it didn't match the answer. So I didn't say, oh, the book is wrong. I kind of did say it, but I didn't stick to it. And I was still open to me making a mistake. And I reread it, and I re-looked at it, and I hemmed and hawed, and I focused on it, and I eventually came up with finding my mistake. So just keep that in mind. We're going to make mistakes. We are all human. We're going to misinterpret something. We're going to miss something as simple as prism, and we're going to go down the rabbit hole. And so just stick with it. Don't give up, and be open to finding those mistakes. Thanks for your patience. I'm going to read more specifically. The base of a triangular prism is a right triangle with a base of 6 inches and a height of 8 inches. The height of the prism is 14. The volume of the... All right, that was surface area. Now we're doing volume. We'll go back to that right triangular prism like this. And we'll turn it just like we did this time. Let's copy. Let's paste. That looks like that. We got lines connecting them. And that's good. And we got dimensions of 6 inches, 8 inches, and a height of 14 inches. Volume equals big B times H. My base shape is a triangle. Base times height divided by 2 times the height of the object. 6 inches times 8 inches divided by 2 times 14 inches. We could cross cancel any of these. We can cross cancel these because it's still multiplication. And 6 times 8 is 48. And 48 times 7 gives me 336. What? Volume equals 336 inches cubed, though. So that's kind of interesting that we get the same volume as, oh no, we had 384. Sorry, I thought 336 was 336 there plus the 48. Yeah, so 336 inches cubed. The base of the hexagon pyramid has an area of 30 square inches. The height of the pyramid is 6 inches. So we can go back to our hexagonal, and we have our sides again that all go up because it's a pyramid. All go to that point, and the base area, the hexagonal base area, is 30 inches squared. So this is 30 inches squared, and then the height of the pyramid is 6 inches. So that's to the bottom here. That's going to be 6 inches. Volume equals 1/3. We got to remember it's a pyramid. 1/3 big B times H. Volume equals 1/3. My base area is 30 inches squared times 6 inches. And we can cross cancel. 3 goes into 30, 10. And that's going to give me a volume of 60 inches cubed. We have inches squared times inches gives us inches cubed. All right, now we're flowing. Find the surface area of the solid. Good. Okay. So we have a front, we got a right, we got a left, we got a back, we got a bottom, we got a top left, top right, top back, top left. So those will be fun. It's a square, so we know that each of the faces of this pyramid are going to be the same with a slant height of 8 yards. All right, so we got a bottom. So surface area. We have a bottom. We have a lateral area. And then we have a lateral area of our pyramid with no bottom. So the base is going to be the bottom, which is 6 yards squared. The lateral area is going to be remember, it's the perimeter. So 6 plus 6 plus 6, which is 24. So that's going to be 36 yards squared plus, this is going to be 36. 6 times 4 is 24. 24 yards. That's adding sixes, so it's just yards times my height, which is 4 yards. That's this. This is the waist of this thing. Plus, then we have 4 pyramids, which is base times height divided by 2. So we got 36 yards squared plus 24 times 4. 24 times 4 gives us 96 yards squared. And then plus the 4 and the 2 are going to cancel. So that's going to be 2 times my base is going to be 6 yards times my height, which is my slant height, which is 8 yards. So we got 96 and 36. 36 plus 96 makes 132 yards squared. Now 6 times 8 is 48 yards squared times 2, which gives us 96 yards squared. And that's going to give us 132 plus 96 gives us 228 yards squared is going to be our surface area. Square yardage because it's surface area. And we get a total of 228. All right, we're not done. We're not done. We got one more. A store pays $2.50 per pound for cat litter. 1 cubic foot of cat litter weighs 48 pounds. Wow. 1 cubic foot. That's a lot. That's a lot of cat litter, but that's pretty heavy. That's pretty dense. What is the selling price of the cat litter in the container shown when the markup is 20%? Okay. So first thing we have to do is find how many cubic feet are in this, the volume. So we have to find the volume, which is big B times H. Volume equals base shape is length times width times height. So we have 10 inches times 6 inches times the height, which is 8 inches. 6 times 8 is 48. So 480 cubic inches. Notice cubic foot. So we're in inches and foot. So you could divide, you can divide it by not 12. That would be the problem, is a lot of students would divide that by 12. You would actually have to divide it by, 1,728, because it's 3 dimensions. So we're going to recalculate this. This is, we're going to erase this. Well, no, we're not. We're going to erase this because we're going to convert these inches to feet. So they leave the best one for last. So 10 inches is going to be 5/6 of a foot times 1/2 of a foot times 4/6, which is 2/3 of a foot. 2/3 of a foot. So let's cross cancel some stuff. Denominator, numerator. That's it. So we're left with 5/18 cubic feet. Cubic foot. So 5/8. So that's 5/8 of a cubic foot. And so the weight, what is the selling price? $2.50 a pound. Okay, so now we're going to take that volume and we're going to multiply it by 48. We can cross cancel. That's going to give us 9. This is going to give us 24. This is going to give us 3. This is going to give us 8. And so our weight per pound is going to be 40. So our weight is going to be 40/3 of a pound. 40/3? Yeah, 40/3. And we're going to multiply that by $2.50. So let's do 40 divided by 3 equals that times 2.5 gives us cost. Cost is going to equal $33.33. And if we're going to mark it up 20%, we actually don't multiply it by 0.2. We actually multiply it by 1.2 because we want the initial cost plus the addition. This is the initial. This is the $33, and then this is 20% of the $33. So we'll take that and multiply it by 1.2, which gives us final cost. Look at that. Final cost equals a nice, clean, even $40. How fun is that? That, kids, is why you do so many problems. So when you rip through this, it makes sense and it's easy and you attack the problem. You're not guessing at the problem. You're not figuring out, wondering if you got it correctly. This was a pretty long video. So those people who already did 7.10, good luck. I hope you did well on that. I'm going to check those scores.